All right, so this is a walkthrough on how to do part 2 of the circuit lab using the Graphical Analysis app or the program for Mac or for PC. So it might look a little bit different. This is the one for PC, but it should be pretty similar. I've got a little bit more room. I've tried to do it on my phone before, and it's a little bit more difficult, but you guys are great with small screens and stuff, so I'm sure you'll be fine. I'm going to use the fake data that's shown over to the left, but you should be using the data that you got for part 2 of the circuit lab. If you didn't finish that, you can be using the data that I put up on the Google Drive earlier, and that should be linked above. So you should have your data available. You should have the graphical analysis program up and running either on your computer or on your phone. And eventually we'll look at the blue sheet for the graphical method summary. But I'll have it here so you can see what I'll point everything out you need. So if you don't have it in front of you, that's fine. So if you don't have everything running, then pause the video and come back when you've got your data in front of you and graphical analysis running. So the first thing we're going to do is we want to do manual entry. And again, this might look a little bit different on the small screen, but that's what you're going to do. So you're going to do manual entry. And then here is the setup here. Now, I'm kind of new to this. I've done it a couple of times, but it should be pretty similar. So for our x-axis, we're going to put in our resistance. And I'm going to come up here and do I double click? No, I think I click on these little dots here, and I can do column options, and I'm going to call this resistance in ohms. This program won't necessarily replace things for you the same way that the full Logger Pro version would do, but it's nice that it's right there on your phone and everything. So for the second Y column, I'm going to hit column options, and it's going to be current, which is measured in amps. And then apply that. And then we're just going to put our data in. So you put your data in. I'm going to go ahead and put what I've got here. All right, so I've got my data in. If you don't, you can go ahead and pause the video and come back to it when you've got all your data in. All right, so if we go here, down at the bottom corner over here, there's a little graph with a curve. And right here, if you click on it, you can go to Apply Curve Fit. It treats everything like a curve. And if I come in here with a linear curve and I apply it, you can see that it doesn't look very good. If you look at if you ran the statistics, which it gives you all the stuff that you would need, you would see that the RMSE is going to be pretty bad. The correlation, does it even show me the correlation here? I don't see a correlation. That's surprising. But the over-under test is the thing that really gives it away. So in this case, it's so obvious that it should be linearized, that this is a curve, that you don't really even have to go through the statistics, and because it's obvious. If you look at the over-under, it starts up here up here at the top of the graph, and then it goes under, and then over again. And you can see that it's a really nice curve right here. That it starts up here and it's curving like this. So we want to linearize this. This is not a linear fit right now. So if we go to the graphical method summary sheet, which looks like this is the blue sheet, the first column gives the graph shape. The second column tells you how to say the relationship out loud or to write it in words. The third column is what you need to do to linearize that shape of data. And then the fourth column is what it would look like in equation form once it's linearized. So you want to look at something where the data points are the shape that you're looking at. A lot of people would want to go to this one right here, this one here, but that is the line that you put on the data, but we already said that that line isn't really a good fit for the data. If you look at the data points, it actually looks much more like this one down here. It looks like it's curved like this. It's a hyperbolic curve, or it's inverse proportion. So y is inversely proportional to x, which means that the current is inversely proportional to the resistance. This third column tells us how to linearize it, and it's replace x with 1 over x. So you take whatever values you had on the x-axis and you want to find the inverse of them, 1 over that number, and use that instead of x. So that's what we're going to do. Let me minimize this. And we can do that here by putting in a new calculated column. So if we come over here to where it says data set and we click here, we want to do, where do I do this? I'm going to pause and make sure that I'm in the right place. All right, I'm back. Actually, come over here to where the current is and you click on these dots and you want to add a calculated column. So again, I'm clicking on the little dots next to one of the columns, add calculated column. So I'm going to click on this and I want the column to be inverse resistance because, and let me show this to you too, that if you look here, we want to do 1 over the x value, and on our x-axis is the resistance. Our independent variable is the resistance. So we want to have a column that's inverse resistance, or 1 divided by the resistance. So we're going to click on these little dots in a column and do add calculated column here. And we want to call that column inverse resistance. And the units are going to be 1 divided by ohms. And for the expression here, oops, I want to do the inverse, which I'm going to say right here is going to be a over x, this one up here, where the parameter a is 1, because we want to do 1 divided by, but we want to do divided by the resistance. So I'm going to change this, click on here, and choose resistance, because it's inverse resistance. So again, you go and choose the a over x expression, keep the a at 1, and change the column x to be the resistance. And then we're going to hit apply. All right. Then we're going to come back over here. We can get rid of this linear fit that we had before. And you can see in our columns now we have our inverse resistance. The computer went in and did it for us and calculated all that for us. So we're going to come here and regular click on the x-axis where it says resistance. And instead of resistance, we want to put 1 over resistance here. It's nice that actually we don't have to right click and auto scale from 0. It does it for us, which is beautiful. And now we can see that this looks way more linear than what we had before. We're going to come over and click on the graph tools in the corner over here. And then we're going to apply curve fit. And we want a linear curve fit. And here we go. So that is our equation here, our mathematical model. Now, one of the biggest drawbacks, there's a couple, but one of the biggest drawbacks of the graphical analysis versus the Logger Pro is that it will give you the y equals mx plus b, but it does not plug in any of the actual variables, because we don't care about y, we want to be about current, and we don't care about x, we want to be inverse resistance. And it also will not put the units on the slope or the y-intercept. So if we come over here, I'm going to go ahead and write a little bit of this out right here next to my data. So it gives us that our equation is y equals mx plus b. But our y-axis is the current, and the variable for the current is capital letter I. Our slope is 1, or my slope, you use your own numbers. You should be using, your data here. 1.92, and then it doesn't show the units. I have to figure out the units for myself. So if I go back over to the graphical analysis, the slope is the rise over run, or the change in y over the change in x. So I'm going to use the units of the y-axis divided by the units of the x-axis, which is going to be current over, the units here are A for current, and 1 over ohms for the resistance. So that's going to be the slope here is going to be A divided by 1 over R. I'm sorry, 1 over ohm. That is wrong. 1 over ohms. And then my X value is what's on the X-axis, which is 1 over the resistance, plus my Y-intercept is super small, 0.000986. 0.000986, and the y-axis units are amps. That's super small, and so I could probably drop it and just make it a 0, because compared to my numbers on my y-axis, it's definitely very small. So, but one thing you might look at here, when you look at the slope, notice the units of the slope are 1 divided by the resistance there, or I'm sorry, amps divided by 1 over ohms. And some of you might know that if you divide by a fraction, it's the same thing as inverting and multiplying. So if you inverted 1 over ohms and multiplied it by amps, you would get amp ohms. So another way to write the slope, I would take it either way, but 1.92 amp ohms is another way to write the slope. And that's pretty much where you need to be for this today's activity or lesson or goal, is that now you need to put in your slope into the box in the Canvas quiz, and you can either write it down like this, or you can write it down like this. And then the second line would be the voltage that you kept the same the whole time, your constant voltage value. In my case, I made this up as being 2.0 volts. So in the Logger Pro or in the Canvas, I would write down something like 1.929 amp ohms. And in Canvas, it's hard to get the little omega symbol. I had some kids that put it in Canvas. I don't know how to do it. If you know how to do it, let me know. And then the second line would be the constant voltage. So in my case, it would be 2.0 volts, right? And put that in and you're done for the day. I hope everything's going really well. If you have any questions about any of this or anything else, you can call me or you can email me at any time. And that's it. So bye.